The definition of a dwarf planet was established by the International Astronomical Union (IAU) in 2006, primarily to classify objects within our own solar system. This definition states that a dwarf planet is a celestial body that orbits the Sun, has sufficient mass for its self-gravity to pull it into a nearly round, hydrostatic equilibrium shape, has not cleared the neighborhood around its orbit, is not a moon. Dwarf planets in our solar system. Currently, the IAU officially recognizes 5 dwarf planets in our solar system. Ceres, located in the asteroid belt between Mars and Jupiter, it's the only dwarf planet in the inner solar system. Pluto, once considered the 9th planet, it resides in the Kuiper belt beyond Neptune. Haumea, also in the Kuiper belt, it has an elongated shape due to its rapid rotation. Makemake, another Kuiper belt object, it's thought to have a reddish color. Eris, located beyond Pluto in the scattered disk, it's slightly smaller but more massive than Pluto. Beyond our solar system. The concept of exoplanet dwarf planets. While the IAU's definition of a dwarf planet is specifically for objects orbiting our Sun, the underlying physical characteristics, being nearly spherical due to self-gravity but not having cleared their orbital neighborhood, could, in principle, apply to objects orbiting other stars, exoplanets. However, the term dwarf planet is not typically used for exoplanets. Instead, these bodies are generally referred to as exoplanets and are further categorized by size and composition, e.g., super-Earths, mini-Neptunes, gas giants, rocky planets. Characteristics of exoplanet dwarf planets, if they were to be categorized as such. If we were to apply the dwarf planet criteria to exoplanets, such objects would share key characteristics with their solar system counterparts. Orbital period. They would orbit a host star, similar to how dwarf planets in our solar system orbit the Sun. Hydrostatic equilibrium. They would be massive enough for their own gravity to pull them into a roughly spherical shape. This implies a certain minimum size and mass, though the exact threshold can vary based on composition. Uncleared orbits. They would exist in a region of their star system where other similarly sized objects or significant debris are present in their orbital path, meaning they haven't gravitationally dominated their orbital zone. Composition. Similar to our own dwarf planets, their composition could vary from rocky, like Ceres, to icy, like Pluto, Eris, Haumea, and Makemake, depending on their formation location and the characteristics of their host star and protoplanetary disk. Detection methods for exoplanet dwarf planets. Detecting exoplanets, especially smaller ones that might fit a dwarf planet description, is challenging due to their small size and faintness compared to their host stars. Most current exoplanet detection methods are indirect. Transit method. This involves observing slight dips in a star's brightness as an exoplanet passes in front of it. The size of the dip can indicate the planet's size. Radial velocity Doppler method. This method detects the subtle wobble in a star's motion caused by the gravitational tug of an orbiting planet. This provides information about the planet's mass. Gravitational microlensing. This technique utilizes the temporary brightening of a background star when a foreground star and its planet pass in front of it, bending its light. Direct imaging. This is the most difficult method and involves directly observing the exoplanet, usually by blocking out the glare of its host star. This is most effective for large, hot planets far from their stars. While we can detect exoplanets with characteristics that might align with the dwarf planet definition, astronomers primarily focus on their orbital parameters, mass, and inferred composition rather than classifying them as dwarf planets, in the same way we do within our own solar system. The sheer number and diversity of exoplanets suggests that bodies analogous to our dwarf planets are likely common throughout the galaxy.